Hello everyone. Last time we did the heart, the circulatory system. Today we're going to learn about the blood vessel that the blood actually travels in. Let me go into a little bit more detail. So remember, we illustrate the oxygenated blood in red and the deoxygenated blood in blue. So here's a simple diagram of what happened, where does it kind of go. So the red one, let's start here. The blue one goes to the lung and picks up fresh blood and then goes into the left side of the heart and gets pumped out through the aorta and the carotid and all that up to the brain, and it gets exchanged and come back down to the superior vena cava. Okay. And this goes all the way down to the liver, stomach, kidney, and all that, and then to the lower body. And then whenever it's used up, it gets exchanged, carbon dioxide with oxygen, and then it returns the used blood or the deoxygenated blood back to the heart, and again to be pumped to get more oxygen. So that's how we pick up nutrient and oxygen and all that. Okay? It dumps carbon dioxide in the lung and the metabolic or chemical waste in the kidneys. You recall that there are two systems, the pulmonary system and the systemic system. Pulmonary goes to the lungs, and the systemic system goes to the rest of the body. So remember this, how the heart is, the blood returned to the right atrium, oxygen is poor, but carbon dioxide is rich. Okay, you remember the vessels are reversed when it comes to, these guys would be the veins. These guys would be the artery, and then these guys coming back would be the veins. Okay, even though it's oxygenated blood on the left side. Okay. How does blood get to the cells and to the heart? And we saw these. So they also have names for big arteries and small arteries and things like that. So big arteries are called arteries, okay, leaving the ventricles. And as it gets smaller and smaller, it becomes arterioles. Arterioles become capillaries, where they are the smallest diameter, where exchanges occur. Only one blood cell can go through. Okay. Now, so it goes here, arteriole, capillaries here, and once it gets through, it's going to become bigger again. Okay. Going back to the artery, capillaries become venules. Okay, and it becomes veins. Okay, that's easy. So they all have, they all look kind of similar. They have share structure. They have a lumen. A lumen is a space where the blood goes through. Okay. There's three layers. Okay. Tunica intima. The intima is the most inner layer. Okay. Simple squamous. The media, again, M for muscle. That's where the smooth muscle is. And then the externa is the outside where it's elastin and collagen. Smooth muscle is controlled by the autonomic nervous system. Of course, you can't control your blood vessels. So it looks like this. So you can tell right away this is a vein because it is not round. It is collapsed. So veins are more elastic. Let's study it here. So, arteries and veins. General appearance, thick wall with small lumen, generally round, as you can see. Thin walls with large lumen, and generally flattened. Okay, so if we see this in the slide, we know this is a vein, okay, and we know this is an artery. The three layers, the intima, media, and externa. Okay, so normally the media, the thickest layer, okay, we're going to study why, and normally thinner than the externa is is smooth muscle and collagen. Okay, so it is thinner here, much thinner here. Okay, as you can see comparing the two. Okay, again, arteries sends blood away from the heart and deliver bloods everywhere. Okay, overall, it has thick walls, it has to withstand greater pressure. Reason being, you remember the ventricle will squeeze the blood. The reason it is a lot of pressure is because it has to squeeze to the rest of the body. Okay. Elastic or conducting closest to the heart with a lot of pressure. So the heart, let me see. I'll show it to you later, the later slides. When it's closest to the heart, it has the most pressure, greatest pressure, because that's where everything originates, right? Has the most elastin in all three layers, more elastin than muscle. It allows expansion. Okay, so a lot of blood coming through, it needs to expand. Okay. Muscular distribution, further away and less pressure. Media, mostly smooth muscle, more active in vasoconstriction and vasodilation. And we're going to see why. There is, the smooth muscle is for vasoconstriction and vasodilation. Also has the ability to control the blood pressure. So whenever there is, whenever your blood pressure is low, so it's not enough pressure, it will squeeze the muscles. Okay, it will squeeze the muscle to make the lumen, the hole, smaller, so blood will get through. Blood will get through stronger. So that's one way to regulate the blood pressure. So with vasoconstriction and dilation, it is how the arteries is the main primary mechanism of distributing the blood everywhere. Okay, you can see artery, muscular artery, and even the arteriole, which is a smaller than the artery, has 3 layers. Okay, so that's the artery. Okay, here's the arteriole. Okay, it also has 3 tunica. Okay, but is much thinner. Okay, critical to slowing blood flow by providing resistance, which regulate blood pressure. So imagine a full class of people needs to go through a small door. Everybody has to go through one at a time. Okay, so it will slow down. Okay, by creating more resistance. Okay, directly controls what capillary beds gets perfused. So again, whatever the arteriole, it controls whatever it gets to the capillary. Okay, as it get closer to the capillaries, only endothelium, tunica media, and the band of smooth muscle. So here's the arteriole, and it needs to get through the capillaries, and then it convert into what? The venues, and then back to bigger veins. Okay, so this term metarteriole, okay, comes from the terminal arteriole. So at the end of the arteriole has bands of smooth muscle in it. Okay, precapillary sphincter. So there is little thing called a precapillary sphincter. Okay, a sphincter is, it's like this. It can control blood go in and out. Okay, it's like a valve. Okay, acts as a valve. Let's say you need blood here. Okay, then the sphincter will open. If you don't need blood there, it's not going to go in there. So if all the sphincters is closed, then blood will pass directly to the venues. Okay, it doesn't need it, so it will just go straight through. can be flooded or completely bypassed. So it depends on the need of the tissue of the organ. Okay. Capillaries, only tunica intima, designed for exchange. So there is 3 types of ways it can exchange. Permeability means leakiness. Okay, things leak through, they're permeable. Continuous. Okay, common, allow water and small molecule like glucose, hormone gases to get through. Fenestrated, like the small intestines, kidneys, and choroid plexus. Remember choroid plexus in the brain? Okay, it makes CSF. Sinusoidal, in the liver, bone marrow, bone, and lymph node. Okay, so it looks like that. Okay, fenestrated looks like that. And continuous looks like that. Okay. Now going back to the heart, we have venues. Look a lot like capillaries. Okay, postcapillary venues. It's got endothelium and connective tissue. Somewhat porous and permeable. The goal is to reabsorb fluid and to return it back to the heart. The veins get bigger. It's got large lumen. Okay, low pressure. Okay, so it needs valves. And you see here, these valves just look, they look like the semilunar valve. Okay, so it needs, the reason it has large lumen, okay, because there's not a lot of muscles contracting, right? It's not a lot of contraction. So the blood pressure will be kind of low, you know, things will be flowing up, and there's a chance for it to come down. So all these, as it flows up, and then it'll stop, the valve will stop it from coming down, similar to the semilunar valve in the heart. Okay. The media, which is the muscle layer, is thin and poorly developed. Tunica externa is thickest. Collagen is highly distendable. That means it's highly stretchable. Okay. So here's a summary. Okay, you can look at them. Okay, we just talked about pressure is low, pressure is high here. Okay, more round, irregular, or collapse. The vein actually kind of stores, okay, about 64% of the blood. It's like you can call it a reservoir, okay, blood reservoir, because it can hold 64% of the blood volume at any given time. If your body needs more blood, vasoconstriction, and it will send it, okay, to wherever it needs. When it becomes active, blood can be easily redistributed, okay, send the blood to the heart quickly. So some of these things have to understand. Flow must be appropriate to meet the need of the tissue. Pressure drives the blood